These reptiles, which we know today as dinosaurs, first evolved about 230 million years ago and ruled this planet until about 66 million years ago, roughly 160 million years ago. 1,000 years ago, we humans didn't exist. 10 million years ago, hominins like Homo habilis or Australopithecus didn't even exist. And 55 million years ago, you couldn't find a single large-brained mammal called a primate on Earth. So the rule of the dinosaurs was one of the longest-running stories in the history of vertebrates. Unfortunately, the dinosaurs didn't have a space program, so one day they were orbiting the outer reaches of the asteroid belt. The asteroid belt between Mars and Jupiter, just 375 million kilometers away from us, is home to many large and small rocks, most of which are smaller than 10 meters in size. There are also silent giants lurking somewhere, such as the largest object ever found in the asteroid belt, a 940-kilometer monster that will end the story of the dinosaurs. In fact, it was much smaller than this sound. It was a piece of rock with a diameter of at least 10 and possibly 15 kilometers, but it was not Ceracin. But our perspective, imagine a mass almost 1.5 times the size of Mount Everest. You may be wondering why its orbit, which has been constant around the Sun for billions of years, has suddenly changed. In fact, there could be many reasons for this, but the reason is mostly that the orbits of gas giants like Jupiter and Saturn affect the bodies in the asteroid belt in different ways at different times. Because, think about it, all of the bodies I have mentioned so far have elliptical orbits around the Sun, 5 million. There are tens of millions of objects, 10 millions of which are larger than 1 kilometer, so over a time span of hundreds of millions of years, when Jupiter or Saturn are closest to the asteroid belt, Haspel fate has the asteroid belt objects that are closest to them are also different. When a bird is in the wrong place at the wrong time, gravitational forces can sometimes be so great that they destabilize the trajectory of large objects in an airplane, which is what happened some 66 million years ago, most likely due to a nudge from Jupiter on the belt. Collisions within the belt, the Yarkovsky effect caused by the heating of the asteroid faces facing the Sun and the cooling of the other sides, and even the gravitational pull of other stars passing through the interstellar space at that moment. The impact is much less than that of Jupiter or Saturn, and for some reason it is very difficult to know the exact trajectory of this asteroid that deviated from its path, but we know the exact location where it hit the Earth. We know the approximate speed of Jesus at the moment of impact. And when we follow this information backwards, we can see that the asteroid was in the second generation between the Earth and the belt. We calculate that it takes a minimum of 174 and a maximum of 460 days to cover a distance of 5 astronomical units, which is a very short time to be able to do anything, even within the capabilities of our modern civilization. So that if the dinosaurs could understand what was going on, the situation for them was more like this. One day they started to see a new star in the sky that didn't exist before, this little bright one, and as the days went by it got a little brighter and a little bigger in the sky, and of course it wasn't actually a new star at all. It was an asteroid leaving the asteroid belt. The closer it got to the Earth, the more strongly it reflected the Sun's rays, and so it became one of the brightest objects in the sky at night and even during the day once we got close enough, and this meteorite, which was bigger than the biggest mountain on Earth, finally reached the Earth, and the moment of impact was a terrifying event in itself. Imagine the brightest meteorite you have ever seen. Now multiply it by tens of billions, and all the dinosaurs that looked at this strange light that appeared in the sky at that moment were instantly blinded by this glare. Of course, this asteroid, like all other asteroids, started to burn as soon as it entered our atmosphere, but this was no ordinary burning. Normally, 0.95% of small asteroids evaporate into heat, but this asteroid was so large compared to the thickness of our atmosphere that it reached the ground without losing almost anything of its mass due to burning. Think of it this way, since many asteroids entering our atmosphere are only a few centimeters in size, their effect is less than a pebble thrown into a huge ocean. In summary, yes, this piece of rock was as big as Mount Everest, but when you look at the Earth from space, although you can see the Himalayas, it is impossible to distinguish Mount Everest individually. Remember that size is not everything, and remember momentum, which I previously described to you as the amount of magnificence of motion. Momentum equals mass times speed, so there is also speed involved. This asteroid, which was as big as Mount Everest, was able to penetrate our atmosphere at a speed of 20-30 kilometers per second, possibly even 70 kilometers per second. Such energy is unimaginable, but what happened afterwards gives us some clues. The asteroid landed on the northwestern tip of the Yucatan Peninsula in what is now southeastern Mexico, and when we look at it today, 66 million years later, it's not much. We cannot see it, but careful geological studies show that the meteorite opened a crater 180 km in diameter, which we call the Chul crater. Along the borders of this crater there are sinkholes that extend along a perfect ring, which today we call coats. If we could see this crater today, it would look more or less like this. And of course, not only these sinkholes, but also a layer of iridium-rich sediment spread across the planet and dated to 66 million years ago confirms the time and location of this impact. Iridium is a material that is very rare on Earth, but very, very abundant in asteroids. So when large asteroids hit the Earth in addition, we see a jump in the iridium ratios in the rocks of that geological period. In addition, the tiny glass spheres formed under extremely high temperature and pressure in these layers are chemical evidence of the rock vapor formed during the impact. We see a circular gravitational anomaly, and there are hundreds of evidences like this that confirm this collision. By the way, let me give you an interesting detail about asteroid craters. As you can guess, this asteroid did not hit the Earth exactly perpendicularly, it hit the Earth at a certain angle. Yet the crater formed is a perfect circle. For example, look at the lunar surface. Although meteorites hit at almost any angle, all of the craters are in the form of perfect circles. The reason for this is that the energy transfer at high speed completely suppresses those deformations caused by the angle. That is, meteorite impacts are such high-energy events that the mechanisms that determine its formation are completely dominated by the explosion in the collision. So the details that we expect to see in collisions at lower speeds, such as being thrown at an angle, are completely eliminated. Everything is thrown perpendicular to the ground, and everything shoots into the sky, which is exactly what happened on Earth 66 million years ago. If you remember, I have already told you about the power of atomic bombs. I even told you what kind of destruction could be created in Turkey with a bomb that was dropped on Hiroshima. Try to imagine billions of bombs exploding at the same time. The energy transferred to the Earth by a 10-kilometer asteroid was roughly this much. Calculations show that the earthquakes at the point of impact have a magnitude between 11 and 12. Imagine the energy it threw around. Now imagine if we experienced 7 and 10,000 of them at the same time. You can't. Neither could the dinosaurs, because those who would have experienced it were almost instantly wiped out. The earthquakes were so violent that our planet continued to ring and shake like a bell for hours, maybe even days, because seismic waves travel around the Earth over and over again, exacerbating each other at the points where they intersect with each other. The point of impact was not just rocky. The water under and around the asteroid instantly evaporated, but the impact was not powerful enough to completely evaporate the ocean, as the crust of the Earth under the ocean collapsed inward and then suddenly bounced back like a tire. The ocean was like water in a glass and began to bounce. And what a bounce! These tremors triggered mega tsunamis up to 1 kilometer in length. It was at a height of 5 km, and if it was only an earthquake and a tsunami, it was still good. Millions of tons of rocks and magma were ejected from the Earth's surface due to the impact of the impact, and the speed of their ejection was so high that many of them reached the Moon, Mars, and even more distant planets. But those that were heavy enough and slow enough could not escape the gravity of the Earth, and after rising tens or even hundreds of kilometers above the ground, they began to rain on the surface again. Imagine millions of meteorites falling from the sky at the same time. But when tens of millions of these rained down for days, the friction and flames caused the entire atmosphere to heat up as well, so the atmospheric temperature skyrocketed to hundreds of degrees in just a few minutes. Some estimates even indicate that the air temperature could have reached thousands of degrees for up to a minute. Due to the fireballs of oil, the gigantic pterosaurs, the flying reptiles that were the masters of the skies at the time, disappeared with terrifying speed. The impact caused huge fires and mass plant deaths around the world, but this was the least that could happen to plants because the dust and ash ejected by the impact and the soot and dust spewed by the supervolcanoes triggered by the tremors began to cover the entire sky within hours. They acted as a screen that the rays of the sun could not penetrate, meaning that the Earth's surface soon became unable to receive sunlight, which within hours meant the end of photosynthesis. No photosynthesis means no plants and algae. No plants and algae means no plants and algae. No herbivores, no herbivores, no herbivores, no herbivores, no carnivores, nothing for carnivores to eat. The ecosystem instantly began to collapse like a series of dominoes. The Earth's average temperature dropped by 34 streams in just 3 to 6 years, due to particles coating the atmosphere. 3 degrees Celsius, meaning that mass fires would be followed by a global winter. The destruction was not just earthquakes, tsunamis, volcanoes, and fireballs raining down from the sky. The impacts and volcanoes also released abnormal amounts of sulfur dioxide into the atmosphere. I can't even enter here, otherwise this video would take days, but imagine what we go through for weeks or months when there is a tiny earthquake or a forest fire that is tiny compared to the size of the Earth. Now try to think billions of times that. This is how the days passed for the creatures of that period. Of course, nothing is eternal, and so are the apocalypses. The land swallowed by the tsunamis resurfaced within a few weeks. The aftershocks continued for decades, but less and less. The fires landed after a few weeks, the acid rains for a few months. Eventually, the rain turned back to just liquid water. The increase in volcanic activity triggered by the impact continued for thousands of years, but its effects gradually diminished. The sky began to let the sun's rays pass through again for the first time in 15 days or so, and the global winter gradually dissolved over the next 15-20 years. Although it only took a few months, it would take decades for the planet as a whole to reach a new normal. Now you may be wondering how any living thing could have survived such a catastrophe. Obviously the chances were very low, but not zero, so it was 3 out of every 4 species living today have disappeared forever in just hours to weeks, including all dinosaurs except for a narrow line of descendants to birds. Yes, birds are the dinosaurs that still live among us, and thanks to their small bodies and ability to fly, they are relatively safe from destruction. The world was not completely destroyed, but there were some areas where life could continue, albeit with difficulty, and plants capable of photosynthesis continued to live there, although in some areas, plant destruction reached 75%, plants, especially those with hardy seeds and roots, survived the slaughter without much difficulty. With the gradual return of sunlight and the warming of temperatures, seeds that had already fallen to the ground germinated, allowing plants to return with great speed. Ferns in particular had a great period after the destruction and had the opportunity to spread all over the world. Almost all 4-legged animals weighing more than a kilogram were wiped out, both by the effects of the impact and by starvation and disease, with the main exception being aquatic cold-blooded reptiles such as turtles and crocodiles, whose hiding coolness greatly softened the effects of the destruction and also allowed them access to aquatic foods that were relatively less affected by the destruction. For example, amphibians, which can live both in water and on land, were also relatively less affected by the destruction, while the remaining small animals were able to survive on the carcasses of dead larger animals and on plants. Animals that could hibernate survived the hard times thanks to hibernation, and partly thanks to hibernation, individuals of many species with the lowest metabolic rates managed to survive, and therefore a little after 66 million years ago, generations with relatively low metabolic rates adapted to relatively low light and oxygen conditions evolved, and fungi, a group between plants and animals, multiplied comfortably by taking advantage of billions of carcasses on the ground and spread around the world like an epidemic. The champion by a wide margin is the warm-blooded mammals with tiny bodies and a wide range of diets. These are the warm-blooded mammals that can protect themselves from the direct effects of destruction thanks to the holes they can make in the soil. This group of crushed animals, which was the most delicious food of the dinosaurs before, suddenly found a great niche and habitat. On the one hand, they spread to new habitats opened in the environments where the dinosaurs disappeared some 5 million years later. There was no way of predicting that it would change the world forever. So under the influence of the tireless mechanisms of evolution, life managed to cling to our planet in one way or another after one of the greatest catastrophes in Earth's history, diversifying and repopulating the planet at an amazing rate.